good day, everyone. And once again, we're back together. And of course, we are still continuing with at question 6 of the November 2022 exam. So if you haven't subscribed, please just make sure that you're part of the family. And of course, you can also join in as a member. All right, so our membership features are on, and you can get yourself onto our WhatsApp group. If you join in as a member, you can obviously benefit from all our other lessons, our live chats, and also our live Q&A sessions. So you can join in as a member in this case. So let's get right into the question. So we're looking at Doppler effect today. Right, so they say to us, we've got a learner that investigates the relationship between the observed frequency and the frequency of sound waves emitted by a stationary source. The learner moves towards the source at a constant velocity and records the observed frequency for a given source frequency fs, right? They say this process is repeated for different frequencies of the source, with the learner moving at the same constant velocity each time. Right, so they say the graph below shows how the observed frequency changes as the frequency of sound waves emitted by the source changes, right? All right, so they're asking us, they say, name the phenomenon illustrated by the graph. So obviously, we know that this is the Doppler effect. So we know that answer there. Okay, so and please, it's very important that you also know the definition as well. Okay, right, let's go on to 6.2. They say name one application in the medical field of the phenomenon in question 6.1. So remember, in the medical field, we usually use this for ultrasound, isn't it? Okay, usually when they want to test the heart rate of a baby, all right, that is still in the mother's womb, they would use ultrasound, and that uses, in this case, the Doppler effect. Right, now they say to you, write down the type of proportionality that exists between FL and FS as illustrated by the graph. Now, ladies and gents, when you look at this graph, you can see that as you increase the frequency of the source, what happens to the frequency of the listener? It increases, right? So in this case, it must mean that it's a direct proportion, because as the one increases, so does the other one. So in this case, we say that is a direct proportion, okay? Or you can say direct proportionality, okay? So that is how they are related. Right, now they say the gradient of the graph obtained is found to be 1.06. Okay, they say if the speed of sound in air is 340, calculate the magnitude of the velocity at which the learner approaches the source. Now, please remember, in this case, we know that it's the learner that is approaching the source. So you can imagine, right? Whatever that source was, let's just say for argument's sake, it's an ambulance. So there it is, you've got this learner that is approaching. It's the learner is moving towards the source, right? So obviously we are going to now use, and I want you to note, so we say, right, so FL is equals to V plus minus VL over V plus minus VS times Fs. Now, remember, we said one of the things have to be stationary, right? In this case, it's the source that is stationary. So it means that Vs is 0. So already what this tells you, and I'm doing this so that you'll know in this case that you already have one variable out in this case, right? So because Vs is 0, so we know that it's just simply going to be over V. Now, ladies and gents, I know that the frequency of the listener has to be greater than the frequency of the source. Why am I saying that? Because as the learner moves towards the source, obviously they are going to experience a higher frequency than the source. Now, In this case, now, if you haven't watched my lesson on the Doppler effect, please do yourself a favor and do that, right? If I want FL to be greater in this case, what type of fraction does this need to be, right? So it needs to be, in this case, what we call an improper fraction. And in order for it to be an improper fraction, it means the numerator must be greater than the denominator. So in this case, it means that I'm going to have a positive there. So it's V plus VL over V, right? Times Fs, right? So that is what I have, right? So remember, what are we looking for? We're trying to calculate, in this case, the magnitude of the velocity with which the learner is moving. So we're trying to calculate the velocity of the source. Now, remember, of the listener rather. So they said to us that the gradient is 1.06. Now, what would be the gradient in this case? Now, remember, it means that FL is equal to, now if you think of y is equal to m times x, right? So in this case, our y is FL, right? It's equal to the gradient, they said, is 1.06 multiplied by Fs, right? So that is how I would relate the frequency of the listener as well as the frequency of the source, right? So in this case, I'm going to substitute. So remember, I have FL equals to 1.06 Fs, right? So 1.06. So instead of FL there, I'm going to say this is 1.06 times the frequency of the source, right? And what can we do with that? It means that I can just divide both sides by Fs. Sorry, that would be Fs. So I can divide both sides by Fs and it would cancel that. So I've got 1.06 is equal to my V, in this case, is 340. So that's going to be 340 plus VL divided by 340, right? So we can have a mathematical gymnastics there. So that's over 1. So if we cross multiply, we're going to have 340 plus VL is equal to 1.06 times 340, okay? And in this case, to get VL, we're going to have that 1.06 times 340, 1.06 times 340, okay? And we are going to subtract 340, and that gives us 20.4 meters per second. So the learner was moving at 20.4 meters per second. I hope that makes sense, ladies and gents. And the final question, they say the investigation is now repeated with the learner moving at a higher constant velocity towards the source, right? They say copy the graph above in your answer book and label it as A. On the same set of axes, sketch the graph that will be obtained when the learner is moving at a higher velocity. Label this graph B. Now, I'm not going to redraw the graph. I'm just going to use this one. So they're saying we label this one as A, right? So this would be graph A. Now, if the learner was moving at a higher velocity, what am I expecting in this case? Of course, in this case, it means that the graph would have an even higher, I want to just use a different color. It would have an even steeper gradient, right? So this would be graph B. Why is that? Because the frequency of the listener would be even higher than the frequency of the source, right? In this case, it would change to a much higher rate in this case, right? So as a result, I know that the graph or graph B would be even steeper than graph A. And I think that is how the cookie crumbles when it comes to this question. It's 10 marks. And please, guys, make it a point that you really maximize when it comes to the Doppler effect. Otherwise, if you haven't subscribed, please just make sure to hit that subscribe button, and please make sure that you follow us on all our social media platforms, underscore Mlungisi Nkosi, on Instagram, on TikTok. All right, I've been really dishing out some really good content there. Otherwise, ladies and gents, do become a member, okay? And I'll see you guys next time. Shap shap.